All right, so let's solve some trigonometric equations. So, of course, let's start off easy. I have 2 sine x plus 1. So, it's just like algebra. You're definitely going to need a lot of algebra to do these types of problems. I am going to subtract 1 from both sides, and I'm basically solving for this x, and the sign is attached to it. So I get 2 sine x equals negative 1. Then I'm going to divide both sides by 2. And I get sine x is equal to negative 1/2. And by the way, I'm sorry, I forgot to say this at first. Let's say that all of our solutions are going to be from 0 to 2 pi. Okay, so we won't do, because we know that because these functions are circular, they keep going and going and going, we'll just limit our answers to 0 to 2 pi. So then we're going to look on our unit circle. That's why I have it up here for where is it at x sine equal to negative 1/2. And I see right here, hopefully you can see my mouse, it is at 7 pi over 6. So x is equal 7 pi over 6. And also here at 11 pi over 6. Now that's if they ask you for your answers in radians. If they want it in degrees, we can give that to them also, right? So that's 210 and 330. Okay. If we wanted to give infinite amount of solutions, we all know what we can do. We add 2 pi to cosine and sine and pi to tangent, and we add 2 pi k, where k is an integer. So that means it loops around the circle however many times we want it to, on and on. Okay, so let's do another one. Of course, now it's time to do one with tangent. So we have tangent x equals the root 3. All right, this one definitely is an easy one. Well, not too easy, because we have to figure out what tangent, we have to do some calculations, right? So if we go back up to our unit circle, and I'm sorry I have to do this. Let me see, maybe I could just move it down. Let me move it down. Okay, so we have to find where on our unit circle will we get root 3 when we do tangent. And tangent is sine over cosine. And so I already know. But if you don't know, then you would have to calculate it. So I am going to go ahead and give us a little heads up. It's at pi over 3. So pi over 3, if I look at it, I get root 3 over 2 divided by 1/2, which equals root 3. So x is equal to pi over 3. Now we can also, if both of our values are negative, we can also do the exact same thing. So here at 4 pi over 3 is also another answer. And again, if I want to just write this out as one solution, if I wanted infinite many solutions or all of the solutions, I would do pi over 3 plus or minus pi k, where k is an integer. All right. Let's go on to the next one. The next one requires that we use a calculator. So I'm going to pull up my graphing calculator, my free graphing calculator here at www.desmos.com. I'm going to hit graphing. And my problem that I didn't tell you what my problem was, I'm sorry about that. I'll write it here, is cosine, and you'll see, oh, that's not on the unit circle. So cosine theta equal to negative 0.2. So in order to find theta, I need to do the cosine inverse of negative 0.2. All right, so let's do that. So I'm going to go here to my functions, cosine inverse of negative 0.2. And it gives it to me in radians, right? So if I want it in radians, that's the answer that I would use. And if I want it in degrees, I will come over here to my little wrench, click on degrees, and it gives it to me in degrees. Now, this is not my only answer. So let's go back to the whiteboard to talk about it. So theta will lead me to believe that they want the answer in degrees. So let's write it out in degrees. But just in case, we'll say it in radians too. And what was it in radians? 1.77215, something like that, right? So now thinking about cosine, and we have our quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now remember, the calculator only gives us our answers in the first and the second quadrant. So if we have answers in the other quadrant, then we have to calculate those answers. So we can see that our answer is in the second quadrant because we go from 0 to 90 and from 90 to 180. And so that's between 0 and 90. I mean 90 and 180. So 101.534 is in quadrant 2. Okay. So in quad 2. All right. We know that when we have negative cosine and a negative cosine, we can go back and look at the unit circle for this. Let me scroll down to look at our unit circle. So when we're looking at cosine, we're looking at those x values. And where is my x value negative? Well, it's negative in quadrant 2 and in quadrant 3. So I need to find out what my answer would be in quadrant 3. So I have my answer for quadrant 2. Now I need it for quadrant 3. So this is where we're going to use our reverse knowledge of reference angles. So we need to find out what is our reference angle, and then from there to calculate what our angle would be in quadrant 3. So to find our reference angle, if it's in quadrant 2, we need to subtract 180 from 101.54. So we'll do that. Oops. And that gives us 78.45. Now, this is not my answer, right? This is just what my reference angle is. My answer is 101.534, but this is my reference angle for quadrant 1. Now, in order to find my angle that's in quadrant 3, I need to add 180 to the 78.45. So that's going to give me 78.45 plus 180. And that gives me 258. So I have two answers. Oops. My answer, is either 101.534 or 258.45. And that's just something that you have to do when you're using the calculator, because the calculator only works in those two quadrants 1 and 2. Okay. So it's not going to give you those two answers, and most of the time you're going to need two answers. All right, so let's go on to the next problem. We have sine squared theta is equal to 2 cosine theta plus 2. So this time I'm using my identity facts, and I know that sine squared theta, I should probably write everything in terms of cosine. So I'm going to rewrite sine squared theta as 1 minus cosine squared theta, because those two values are equal to each other. So now it looks a little bit more familiar to me, something that I can do. So I'm going to move everything to one side, and I'm going to solve it just like it's a quadratic equation. And I'm saying that I'm solving it like a quadratic because I have that square value, and that square value is kind of like my quadratics, right? So I have 1 minus cosine squared theta, and basically I'm just subtracting this entire side, right? So I get minus 2 cosine theta minus 2 equal to 0. So when I combine my like terms, all right, so I get negative cosine squared theta minus 2 cosine theta minus 1 equals 0. Oops. So I'm going to go ahead and multiply a negative through, and I get cosine squared theta plus 2 cosine theta plus 1 equals 0. And so now this is just like an equation. If I say x is equal to cosine theta, I can say x squared plus 2x plus 1. It's a quadratic equation, right? And when I separate that, I get x plus 1 times x plus 1 equal to 0. So if I plug my x back in, I have cosine x plus 1 and cosine x plus 1, both equal to 0, the same thing. And so equal to 0. Subtract 1 from both sides, and I get cosine, and I've changed it to x, it's supposed to be theta, excuse me. Cosine theta is equal to negative 1. And when we look on our unit circle, the place where it's equal to negative 1 on our unit circle is pi. So theta is equal to pi, or if we do it in degrees, it's equal to 180. Okay, I think I have time. Okay, here's my next one. 2 cosine squared theta plus cosine theta equal to 0. Just like with algebra, I can factor out a cosine. So I have cosine theta equal to 2 cosine theta plus 1 equal to 0. And so I set cosine theta equal to 0, and I set 2 cosine theta plus 1 equal to 0. And so this one I have to solve, and I get 2 cosine theta equal to negative 1. Divide both sides by 2, and I get cosine theta equals to negative 1/2. And then when I look at it, I know cosine theta equal to 0 is at pi over 2. And for negative 1/2, it is at, well, it's at 3 pi over 2 as well. And then for 3 pi, negative 1, it's 4 pi over 3 and 2 pi over 3. And I just brought my unit circle down so that you can actually see it. So when cosine is 0, we have it here at 3 pi over 2 and pi over 2. And then when cosine is negative 1/2, let's see, we have it at 4 pi over 3, which is here, and 2 pi over 3, which is here. Okay, let's do one more. Okay, so I have a double angle this time. So again, I'm going to move everything to one side. And my double angle is at 2x, by the way. And so my 1's cancel out, and I'm left with negative 2 cosine 2x equals 0. Well, I don't really need that negative 2 because I know if I divide by 2, it's 0. So I get cosine of 2x is equal to 0. So now where on the unit circle is cosine equal to 2, 0? Well, it's equal to, not to 2, 0, it's equal to 0. It's equal to 0 at pi over 2. And so I know that if I divide by 2, it is x is equal to pi over 4. Well, what if I added 2 pi to this? And I think I'm running out of time. Okay, so I am running out of time, but we do have to remember that we are staying on the interval of 2 pi. So that means I have to take into consideration what will happen to my equation if I added 2 pi to this. So for this one, I know that x is equal to pi over 4, because if I divide by 2, I get pi over 4. And for this one, if I divide by 2, I get 3 pi over 4. Well, here if I add, I have pi over 2 plus 4 pi over 2. That gives me 5 pi over 2. And if I divide that by 4, I get